Okay, think about something you do every single day. You look in the mirror, right? You see yourself looking right back at you. But what if I told you that person you see isn't really there? Today, we're going to break down the absolutely incredible physics behind one of the most common and maybe most misunderstood objects in your house, the simple mirror.
All right, let's just jump right into the big puzzle, the one that kind of messes with your head. You raise your right hand, and your reflection raises its left, so the mirror flips you left to right. But have you ever stopped to think why it doesn't flip you upside down? Why are your head and feet exactly where they should be? The answer is going to completely change how you see yourself, literally.
So, to crack that puzzle, we've got to first wrap our heads around what a mirror is actually doing. Because what you're seeing isn't a window into some parallel universe. Nope. It's a masterclass in deception, a perfect illusion our brain falls for every single time. That reflection of you, it's not on the surface of the mirror, and it's definitely not behind it. It's what's called a virtual image. It's basically a ghost. A ghost that your brain creates because it's being tricked by the incredibly predictable way light behaves. And to understand that trick, we have to look at the mirror's biggest secret. So, what's the big difference between a mirror and, I don't know, a white wall? Why can you see your face perfectly in one and not the other, even though they both reflect light? Well, it all comes down to how smooth the surface is. And I mean smooth on an almost atomic level. I mean, look at this. It's basically order versus chaos, right? When light hits a rough surface, like a piece of paper, the light rays just scatter in a million random directions. That's called diffuse reflection. It's why you can see the paper itself, but not your reflection. But a mirror? A mirror is unbelievably smooth. So when light hits it, the rays bounce off in a perfectly neat, organized pattern. That's specular reflection, and that's what keeps the image of your face intact. And all of this perfect, organized bouncing, it follows one beautifully simple rule, the law of reflection. All it means is that the angle a light ray hits the mirror is the exact same angle that it bounces off. That's it. No exceptions. This perfect, predictable behavior is the engine that drives the entire illusion. And this is where your brain gets totally fooled. See, your brain has spent your entire life learning one thing. Light travels in a straight line. So when all those perfectly reflected rays hit your eyes, your brain traces them backward, in a straight line, to a point behind the mirror where they all seem to be coming from. And right there, that's where it creates that ghost image of you. Okay, you with me so far? We know how the illusion gets made. Now, let's use what we know to finally solve that left-right mystery. So here it is, the big reveal. You ready? The mirror doesn't flip you horizontally at all. It never has. What you're actually seeing is something much, much weirder, and it has everything to do with a direction you're probably not even thinking about. Just imagine yourself for a second. There are 3 dimensions, right? There's a left to right axis, let's call it X, and an up and down axis, we'll call that Y. The mirror leaves both of those completely alone. Your head is still up, your feet are still down. What the mirror does change is the Z-axis. That's the one that goes from your front to your back. That's it. That is the entire secret. A mirror is a front-to-back flipping machine. Think about it. The tip of your nose is the closest part of you to the mirror. And in the reflection, the tip of its nose is also the closest part. The back of your head is the farthest part from the mirror. And in the reflection, its back is also the farthest away. The whole you is just inverted, perfectly, front to back. And look, this is the perfect way to see it. If you hold up an arrow pointing up, the reflection points up. If you point it to the right, the reflection points to the right. But if you point an arrow at the mirror, forward, the reflection points back out at you. It only, and I mean only, flips along that Z-axis. So, wait a minute. Why does it feel so much like a left-right flip then? Well, the simple answer is you. The trick is happening in your own head. Our bodies are mostly symmetrical left to right, but not at all top to bottom. So when your brain sees this person who's been flipped front to back, it tries to make sense of it. It imagines that person turning around to face you. And how do you turn to face someone? You rotate around your vertical axis, which swaps your left and right. The flip happens inside your brain, not in the mirror. Okay, so we've pretty much cracked the code on flat mirrors, but things get really interesting when we start to bend them. Because when you curve the surface of a mirror, you can start to manipulate light in some pretty amazing ways. You've basically got 2 flavors here. Concave mirrors, they curve inward, kind of like the inside of a spoon. They focus light rays to a point, which can magnify things up close. That's why they're used for makeup mirrors. Then you have convex mirrors, which curve outward. They do the opposite. They spread light rays out. This shrinks the image, but it gives you a massive field of view.
And you've seen this a million times, I guarantee it. That warning on your car's passenger side mirror, it's there because that's a convex mirror. It's giving you that super wide-angle view, so you don't miss anything in your blind spot. But the trade-off is that it shrinks everything down, making cars seem way farther away than they actually are. It's just a little bit of physics, keeping you safe on the road.
All right, I've got one last thing to share with you, and it's a bit of a mind bender. We've talked about how the mirror shows you a ghost in space, but it's also showing you a ghost from a whole other dimension.
You know, we always think of light as being instant. You flip a switch and boom, the room is lit. And for us, day to day, that's pretty much true. But the thing is, light has a speed limit. It takes time for light to leave a lamp, bounce off your face, travel to the mirror, bounce off the mirror, and then finally travel into your eye.
Now, this delay is tiny. I mean, we're talking nanoseconds. It's so small you could never ever notice it. But it's not zero. The person you see in that reflection isn't you as you are right now. It's you as you were a tiny fraction of a second ago. Every single time you look in the mirror, you are quite literally looking into the past. So yeah, the next time you glance in the mirror, remember all the incredible physics and brain trickery that's happening. You're seeing a front-to-back version of yourself from just a moment ago. Pretty wild, right? So what other common, everyday objects should we deconstruct next? Let us know.